Hello. Today I will show you how to develop two-way ANOVA with interpretation. The two-way ANOVA compares the mean differences between groups that have been split on two independent variables called factors. You need two independent categories, variable and one continuous or interval or scale dependent variable. Our assumption here, the dependent variable is either interval or ratio, which is continuous and approximately normally distributed for each combination level of the two independent variable. Then the dependent variable should be homogeneity of variance of the group formed by the different combination of level of two independent variables. The researcher was interested in whether an right was influenced by either, which is socioeconomic status, and gender, which is male and female. They recruited a random sample of 200 participants or students to their study and asked them. The researcher then divided the participants the student by gender, male and female, as you can see it here. Then we separated the individual into three appropriate level or group by using the two independent variable and labeled them gender and SES. For gender we coded male as 0, as you can see it here, male 0. Let me go to the data view, male 0 and female 1. And for SES we have three levels. We code it as level 1 for the low, and the middle as 2, then the high as 3. Okay, then I'll go to SPSS, and this is the data we have. As you can see, it's student, 200 student, which is here, 200 student or applicant, and the variable we have gender, race, SES, school type, program, and read, write, math, science, social study. This is the data we have, and then we have to run the procedure. As we can see it here, first we have to test for normality. How to test for normality? We have to determine whether the dependent variable is normally distributed for each combination of the levels of the two independent variables. I have to go to analyze, descriptive statistic, explore, and then we use the dependent variable right and independent variable, and then we use gender. Then plot, you select STEAM, select histogram, normal plot, and continue. Then press OK. What we have here, the outcome, as you can see it here, this is the test for normality. Right with low level, right with middle level, right with high level. As you can see, all of them, two of them, middle and high level, are statistically significant, which is less than 5% for both Cologrove and Shapiro. This means that both of them statistically significant, means that the data are not normally distributed, except for the right with low level, statistically not significant. But here we conclude that our data are not normally distributed, and in this case we reject null hypothesis and accept the alternative. So our guide is, if we reject null hypothesis and accept the alternative, meaning that the data are not normally distributed. So when p-value is less than 5%, data not normally distributed. But if p-value greater than 5%, it means that the data are normally distributed. This is how to test the normality, and usually with the survey or time series data, with the survey or questionnaire data, the data are not normally distributed, and this is what we have to use, the unrestricted coefficient in this case. So in this case, we have to test again homogeneity variance, as you can see it here in the second table. I'll go to analyze general linear model because we have two-way ANOVA, and then just reset, put the dependent variable here, independent variable, gender, SES, and then contrast, continue, plot. We have to put SAS here, gender and the separate, then add, we can see SES with gender. Press continue, go to post hoc, and then move this variable here, then press continue, then go to EM mean, and then move these three variables here, as you can. Then press continue, then go to option and select descriptive statistic, homogeneity test, then press continue, and then press OK. So the outcome here. First we see that SPSS produces many tables and it is output from a two-way ANOVA. And we are going to start with the descriptive table as shown here. What is the descriptive here? As you can see, the table is very useful as it is provided the mean and the standard deviation for a group or levels that have been split by both independent variables. In addition, the table also provides a total, as you can see it here, because here we are female, male with low level, middle level, and high level, female with low level, middle level, high level, then the total with 3 levels, which shows means and the standard deviation for a group or levels only split by the independent variable or none at all to be known. Then we move to the third table, which is Levene's. This is the third table, Levene's. As you can see it here, we have a guide. In our guide, if p-value less than 5% level, then we would have concluded that the variance across groups was significantly different and equal. But if p-value greater than 5% level, then we would have concluded that the variance across group was not statistically significant, which is equal. In our example, p-value is less than 5%, as you can see it here. Significant, less than 5%, and meaning that we would have concluded that the variance across group was statistically different, which is unequal. This is for Levene's, and then we move to test between group or subject effect table. As you can see it here, this is test between subject effect. You can see correct model, intercept, gender, SES, gender and SES. We are interested in the gender, SES, and gender, SES, and then gender with SES row of the table as highlighted. These rows inform us of whether we have significant mean difference between our group levels for our two independent variables, gender and SES, and for their interaction, gender and SES, which is this one, the interaction of this part here. We must first look at the SES interaction, as this is the most important result. We can see from the significant column that we have statistically not significant, 87.5%, which is greater than 5%, meaning that we cannot reject null hypothesis, rather we accept null hypothesis. Then we can see that the above table that there was significant difference in right between, as you can see it right, between gender, which is significant, 0.00, which is less than 5%, and then there was a significant differences between SES, which is less than 5%, and the interaction, as you can see it here, which is not statistically significant. So the interaction here, as you can see it, greater than 5%, which is statistically not significant. As you can see here, the statistically not significant interaction when p-value is greater than 5% level. Then we move to the comparison table. As you can see it here, comparison table. This is the multiple comparison. As you can see, the dependent variable is right. The variable SES with low level, middle level, and high level, middle level with the low level, high level, and then we can see that we are interested in the low level with high level, which is statistically significant, greater or less than 5%. This means that we are interested in the differences between 1 level and 2, middle, and 3. We can see that low level with middle level are not statistically significant because p-value greater than 5%, but low level with high level is statistically significant because p-value less than 5%. Again, middle level with high level is statistically significant because p-value is 2, which is less than 5%. Then we have to go to the plot. We see plot of the result. The following plot here, as you can see it, we have a guide. Our guide, if there is an interaction effect by inspecting whether the lines are parallel or not. In our example, the lines are parallel to each other, which means that, as you can see it here, which is parallel. From this plot, we can see how our result from the previous table might, which is the multiple comparison, which makes sense. Remember that if the lines are not parallel, then there is the possibility of an interaction taking place. But if the lines are parallel, then there is no interaction taking place. In our example, the lines are parallel, then there is no interaction taking place. And this is what we have short video how to explain, to develop and interpret two-way ANOVA. Thank you.